In today's video, what we're going to be doing is looking at parametric equations and looking at how to eliminate a parameter. So parametric equations are, there's an x equation and there's a y equation, and there's a variable that goes into each of them. So in this case, the parameter is t, which generally speaking means time. And your x would be your horizontal movement based on time, and your y would be your vertical movement based on time. So it kind of allows us to look at one situation in kind of two different parts. Like I said, the x part as a function of time and the y part as a function of time. So to graph it, because we're still going to be graphing it on an xy axis, so there isn't a t variable on here, so we're going to plug the parameters. Okay, and in this case, we're graphing from -3 to 3. And we're going to plug these into each the x and the y to get our ordered pair that we then graph. So we're going to plug -3 into both the x and the y equation, and so on. So we would do -3 squared. So -3 squared is 9. 9 plus 1 is 10. So we would get 10 for this part. Okay, and then we would plug -2 in. And -2 squared is +4, plus 1 is 5. -1 squared is +1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. 3 squared is 9, plus 1 is 10. So that gives us all of our x coordinates there. Then we're going to plug in to the y equation. And so we'll do -3 times 2, which is -6, minus 3 is -9. Then plug in -2 for t. So -2 times 2 is -4, minus 3 is -7. -1 times 2 is -2, minus 3 is -5. 2 times 0 is 0, minus 3. 2 times 1 is 2, minus 3. 2 times 2 is 4, minus 3 is 1. And 3 times 2 is 6, minus 3 is 3. So then we would plot these points. Okay, so then we're going to go over to our xy graph here. I'm just going to make it just a little bit bigger. And then you just plot these. So plot the point 10, -9. So we'll go out to 10 and then go down to -9. 5, -7, 2, -5, 1, -3, 2, -1, 5, 1, and then 10, 3. So what you're seeing here is actually a sideways parabola is what it's ending up looking like. And when we graph these, then we would also talk about which direction it was moving with time. So where did we start at with this parameter, this -3? So this one is going in this direction. Okay? All right, then let's look at one with trig functions in it. So now we've got our x equals 5 times sine of t, y equals 2 times cosine of t. So we're going to be plugging in, from 0 to 2 pi. So using our unit circle. So I'm just going to draw the first quadrant over here of the unit circle angles just to remind us. So we've got the pi over 6, which is square root 3 over 2, 1/2. We've got pi over 4, which is square root 2 over 2, square root 2 over 2. And then we've got pi over 3, which is 1/2, square root 3 over 2. And then you've got your quadrantals. So this one would be 1, 0. This one would be 0, 1. And I'll put in these other ones too, -1, 0, and 0, -1. And then remember that those, maybe I'll put this one in green instead. that these repeat themselves in each quadrant, but with the positive and negative change with the coordinates. So plug into each of these, remembering that sine is the y and cosine is the x on the unit circle. So when we do sine of 0, okay, so sine of 0, y coordinate at 0 is 0. 0 times 5, 0. Sine of pi over 4, okay, so that's the red angle. So sine of pi over 4 is square root 2 over 2 times 5 would be 5 square root 2 over 2. Pi over 2 is this quadrantal, and the sine is 1 times 5 is 5. 3 pi over 4 is going to be in the second quadrant, so it's going to have a y value of square root 2 over 2, still positive. Okay, so because the y value is positive in the second, times 5 would be 5 square root 2 over 2. Pi, what's the y value at pi? 0. 5 times 0, 0. 5 pi over 4 is the pi over 4 reference angle in the third quadrant. So the y value in the third quadrant is negative. So that's going to be a negative root 2 over 2 times 5. So that's going to be negative 5 root 2 over 2. And then 3 pi over 2, the y value is negative 1 times 5 is negative 5. 7 pi over 4 is again a negative y value with that root 2 over 2 times 5. So negative 5 root 2 over 2. And then the y value at 2 pi is 0. 0 times 5 is 0. And then to graph these, I mean, it's going to be hard for you to know where 5 root 2 over 2 is. So I would do the decimal in your calculator. So 5 times root 2 divided by 2 is about 3.53. So 3.5. So this one's 3.5. This one is negative 3.5. This one would be negative 3.5 for when we go to plot those. Then let's do the cosine. So 2 times cosine. So cosine at 0, cosine's the x coordinate. So cosine of 0 is 1 times 2 is 2. Cosine at pi over 4 is root 2 over 2 times 2. So the 2's are going to cancel. When you do 2 times root 2 over 2, then those would cancel. So this is just going to be root 2. At pi over 2, okay, x coordinate is 0. 0 times 2 is 0. At 3 pi over 4, the x coordinate in the second quadrant is negative. So this is going to be negative root 2 over 2. Negative 2 root 2 over 2. So those 2's are still going to cancel. So it's just going to be negative root 2. At pi, the x coordinate is negative 1 times 2 is negative 2. 5 pi over 4, the x coordinate is still negative. Okay, so it's going to be negative root 2. 3 pi over 2, the x coordinate is 0. 0 times 2 is 0. 7 pi over 4, the x coordinate is positive in the fourth quadrant. So it's just going to be root 2. X coordinate at 2 pi is 1 times 2 is 2. Then again, you'll want to calculate what the square root of 2 is so that you can actually graph that. So that's 1.4. So then this is going to be negative 1.4, negative 1.4, 1.4. Then we can just graph all of these. So we'll plot 0, 2. 3.5, 1.4. So here's 2, 3.5, 1.4-ish. 5, 0. 3.5, negative 1.4. 0, negative 2. Negative 3.5, negative 1.4. Negative 5, 0. Negative 3.5. Oops, that was negative 2.5 that I did there. Sorry, negative. So the first one was negative 3.5, negative 1.4. And then this one is negative 3.5, positive 1.4. And then 0, 2 overlaps back on here. So this one started at this point and went this way. And what you actually get is an ellipse. And then again, the direction of it, so we started here and went this way. So this is an ellipse, or like an oval. So we're going to talk about how to eliminate the parameters and then determine what type of equation it is. So you've seen two things now. We did a sideways parabola, so we had a parabola here, and then we had an ellipse. So you could end up with lines, parabolas, ellipses, or hyperbolas. And what hyperbolas are is they look like this. Okay, so they go, it's almost like two parabolas. So either a parabola going up and down, or those parabolas could be going left and right also. So you could have hyperbolas going left and right. So it could be this way. So what you're going to look for once you eliminate the parabola, or the parameter that I'm going to talk about on the next screen, if you have no exponents bigger than 1. So you either have just an x, just a y, or you have both an x and a y. Okay, so if you end up with something like x equals 5, that's a straight line. Or y equals -2, that's a straight line. Or x equals 3 plus y, that's a straight line. Okay, there's no exponents bigger than 1, and you just have either the x or the y or both. For parabolas, you need to have both variables. Okay, so you can't just be down to one variable. You need to have both variables, and one of them is squared. Okay, so you could end up with something like this: x squared plus y equals 5. You have both variables, one of them is squared. This would be a parabola. Okay, or you could have x plus y squared equals 3. Okay, both variables, one is squared. That's a parabola. Hyperbolas, you again are going to have both x and y. Both of them are going to be squared. And either one of them is negative, not both. Okay, it can't be both negative, but one of them is negative. So you're going to end up with something like this: x squared minus y squared equals 5. That's a hyperbola. Or it could be negative x squared plus y squared equals 6. Hyperbola. Both are squared, one is negative. For an ellipse, you're again going to have both variables. Both of them are going to be squared, and they are both going to be the same sign. So you'll have something like this: x squared plus y squared equals 12. Both squared, both positive. Okay, or you could end up with something like this: x squared minus negative x squared minus y squared equals -4. Okay, both of them are negative. So then this is going to be ellipse as well, because what you really should do here is divide everything by -1. And then you'd get x squared plus y squared equals 4. So then you'd have them both positive. Okay, so check out this list when you get to the end of each of these problems. So here's how we're going to eliminate the parameter, okay, by doing substitution. So I gave you steps over here. So the first thing you need to do is solve the first equation for t, the parameter that you're getting rid of, okay? So I'm going to solve this equation for t, which means I'm going to get t by itself over here. So I'm going to subtract 3 from both sides. Okay, so once I subtracted 3 from both sides, right, you get x minus 3. This 3 is gone, and you just get -2. T. Then you're going to divide by -2. Okay, so now we have x minus 3 divided by -2 equals t. That's step 1. Okay, now you're going to substitute this back into the bottom equation. So this is what t equals. You're going to substitute that in for t in the second equation. So we've got y equals 2 plus 3 times t, which is x minus 3 over -2. So now you will no longer have a t in there because you just wrote it in terms of x. So now you'll simplify this. So we have y equals 2, and we'll multiply this 3 in. Okay, so we'll multiply it to the top. The bottom is a 1. Okay, so you'll get 3x minus 9 over -2. Now we're going to split this so we can simplify a little bit further. So we're going to divide this -2 under each of these. So we get 3x over -2 and we have the minus 9 over negative 2. Okay, so this is 2. And then you can do a plus. I'm just going to put this negative as out front of this. So I'm going to put this as negative 3x over 2. And then negative over negative is positive. And I'm going to do this as a decimal. So you could have done this one as a decimal too if we wanted to. Actually, let's do that. So let's do this as negative 1.5x. Negative 9 divided by negative 2 is positive 4.5. So then we'll have that negative 1.5, and positive 2 and positive 4.5 is positive 6.5. So then we'll figure out what type of equation this is. We don't see any exponents higher than 1, so this is a line. So you eliminated the parameter and said what it would look like when you graph it. Okay, next one. So we're going to solve for sine of t and cosine of t. So we're going to get them by themselves. This top one's already done. You have cosine of t equals x. This bottom one, you have 2 sine of t. So we need to divide by 2. So then we'll get y divided by 2 equals sine of t. Okay, so now you have what sine equals and what cosine equals. And I'm just going to write it with the cosine on this side. So cosine of t equals x. Sine of t equals y over 2. Okay, so that was that first step is done. So now using the Pythagorean identities that we learned, we know that sine squared plus cosine squared equals 1. So we're going to substitute these in. Okay, so where I see cosine of t, I'm going to plug in x. Okay, so where I see cosine of t, I'm going to put x. And then where I see sine of t, I'm going to put y over 2. Okay, so here's sine squared of t. Okay, so instead of sine, I'm going to write y over 2. And now it's squared because you've got the sine squared. Okay, plus you have cosine squared. Okay, and instead of cosine, I know that cosine is x. And then equals 1. So now we'll square this. So you square top and bottom. So this is y squared over 4 plus, this is just x squared, and then equals 1. And then you can leave it like this, or we can multiply by the least common denominator so that it doesn't have a denominator, which would be 4. So multiply everything by 4. So 4 times this will be gone. The 4's will cancel. So we'll just get y squared. 4 times x squared. And then 4 times 1, so if you wanted to. I'm not going to do that because this actually right here is the standard form of how we would write an ellipse. Okay, and we can tell that this one is an ellipse, again, because we've got, if we go back to our list here, we've got both an x squared and a y squared, and they're the same sign. Okay, x squared and y squared, both are positive, so this one is an ellipse. Okay, so solve this top one for t. So I'm just going to write that down here. So I'm going to subtract 3 from both sides, so I'll get x minus 3 equals 2t. Then divide by 2. Okay, so that's that first step. Then substitute it into the other equation. So we have y equals t squared minus 6. So t being x minus 3 over 2 squared. Then you can simplify this, and the only thing I would really do here is bring this squared to the top, and then the squared to the bottom. So 2 squared is 4, and then you have the minus 6. Then you can multiply both sides by 4. If you wanted to get rid of that 4 on the bottom, so we can just multiply everything by 4. So we'd have 4y. And then equals, so when you multiply times 4 here, those bottoms would cancel and you'd just be at x minus 3 squared. And then 4 times 6 is 24. So you could have it like that. You could leave it like this too, this first one. And if you just left it without manipulating it here like this, you'd still be able to tell, hopefully, that there's a squared here. So this is going to square the x. So we've got both the x and the y, and one of them is squared. So this is going to be a parabola. All right, one last one with trig identities. So let's solve them for tangent and secant. So we're going to divide by 3 here. So we would get that tangent of theta equals x divided by 3. This bottom one will divide by 2. So we're going to get secant of theta equals y divided by 2. Okay, so tangent is x over 3. Secant is y over 2. And then we're going to plug into this Pythagorean identity. Okay, so instead of tangent squared plus 1 equals secant squared, instead of tangent, we're going to plug in x over 3. And instead of secant, we're going to plug in y over 2. Then we'll just simplify it, so we'll square the top and the bottom. And then we'll square the top and the bottom here. And so now whoops, I forgot to square the bottom. 2 squared on the bottom there is 4. So now we have both an x squared and a y squared. They need to be on the same side for you to be determining whether they're the same sign. So I'm going to subtract this x squared over 9 from both sides. So I get 1 equals y squared over 4 minus x squared over 9. Okay, so on the same side, we have different signs. We've got a positive y squared and a negative x squared. So this one is a hyperbola.